Hey guys, welcome to another edition of Maro Teaches Online. As always, a shout out to my followers. I couldn't do it without you. Alright, so for today, we're doing the second day of how do we transform quadratic functions. So, there's the homework. Let's check the homework. So first of all, vertex. The vertex will always be either the highest point or the lowest point. So if you look, that's where it gets to its highest point. So what coordinates is that? 4, 3. So that should be easy. Is the vertex a max or a min? Well, clearly it got up to its highest point, so that's a maximum. But if you ever forget, again, if it looks like this, that's a maximum. Okay, if it ever looks like this, that's a minimum. So that's the easy way to remember it. Now, anytime you see the phrase axis, it kind of sounds like we're saying x is. So like x equals, and then whatever your x equals, that's your line of symmetry. Okay? When is the function decreasing? When is it increasing? So here's where the axis of symmetry is. It goes right down the middle of the U. So basically, what is it doing on this side of the graph? You can see how it's increasing on this side of the graph. So on this side of the graph, on the left side, it's increasing. Okay, what's it doing on this side of the graph? Well, on this side of the graph, it's decreasing. It's going down. Just think of it like a roller coaster. So on this side of the graph, it's decreasing. So just think of it like an arrow pointing to which side of the U we're talking about. So on the left side, it's increasing. On the right side, it's decreasing. And then for range, remember, domain is X, range is Y. So that's where the Y comes from. Then use whatever your Y value is for your vertex. There it is. And is the U going up or is it going down? It's going down. So that's why it's less than or equal to. Okay, so that's all. Remember, you can always pause the video if you want to see it. And here we go. Okay, so if the original graph is x squared, then graph 2x squared plus 4 would be what? So remember, that plus 4 tells you it's going to go up 4. And if the number is bigger than 1, it makes it more narrow or narrower. So again, if you look at the red U, that's your standard U. And what's the blue U doing? It went up 4 and it got skinnier, which is narrower. And don't forget to label, don't forget to draw arrows. Okay, so this is where you just got to remember all your transformations. So remember, the 2 makes it narrower. And then that minus, if this thing would stop glitching on me. Oh my goodness, stop it. Okay. And then the minus, remember, it either reflects over the x-axis, or the other way of saying that is it opens downward. You can see how the opening is down. Okay. This one just goes down 7. This one goes up 4. And if it's a fraction that's less than 1, it gets wider. So again, it would have moved up 4, and it would be a wider U. The next question. So axis of symmetry. So the way to remember the formula is x's are not brought to anniversaries. Don't bring your x's to anniversaries. It's not going to end well. So remember, this is your A, this is your B. So whenever you see a minus in a formula, think opposite. So the opposite of negative 16 is positive 16. So that's where the 16 came from. And then it says 2 times your A. So 2 times whatever your A is, which in this case is negative 8. You solve it. So 16 divided by negative 16 is negative 1. But remember, your final answer has to say x equals negative 1. You can't just leave it as negative 1 because it's axis of symmetry. X equals negative 1. And then it says use this to find the vertex. Well, you got part of your answer. We just figured out what the x is. The x is negative 1. Now we got to figure out what the y is. So all you got to do is go back to the equation, and anywhere you see an x, What did we just get? -1. So just plug it in. The only thing you really need to be careful of anytime you substitute, put it in parentheses because it tends to mess up if you don't. So when you type that all in your calculator, you get that the y is -1, and that's where the vertex came from. So same question over here. What's your A? Oops. What's your A? -5. What's your B? It's 20. Okay, because again, A is -5, B is 20. So it should be negative B, so -20 over 2 times your A, which is -5. So -20 divided by -10 is 2, but remember the answer is x equals 2. And remember, you just plug it back into your equation, and that's how you can figure out what the y is, and that's your vertex. And you can always graph the equation on your calculator and just see where the vertex is so you know what the answer should be. Okay, factoring. This stuff is review, so hopefully you remember it. Again, you're just square rooting. If this thing would stop glitching for the 100th time. Square root 25, square root 36, that's where the 5 and the 6 come from. Each one gets an x, each one gets a y. What do you always look for first? Always look for GCF first. So what can you take out? You can take out a 12 out of all of them. You can take an x squared out of all of them. What's left? That's what's left. And there's no way to factor this trinomial. So it's not like it was factored completely where you could go again. C is just a basic trinomial. You all should have gotten that. And D is one of those tricky trinomials. So 3x, multiply the front with the back. That's where the 84 came from. 7 times 12 is 84. And when you add it, you get 19. You can't take anything out of the first one, but you can take out a 3 out of the second one. And you could always check it by graphing it or doing box and FOIL. Okie dokie. Okay, this one was factored completely. It was GCF first. There it is. It was GCF first, so you could take a 2 out. There's the remaining, and then you would just factor that trinomial, and there's your answer. And then for number 7, you actually would do a trinomial first, and then if you notice, that one is dots, so you would keep going. This one is not dots because you can't have addition, nor is 2 a perfect square. So that's no good. Okay, so here comes now the second day of transformations. So most of it's pretty easy. There's only one little hard part, and that's when you have to write the new equation. The beginning part of the lesson, not terrible. The end, you're not going to probably like, but I'm sure you'll be fine with it. So first of all, let's describe the transformation. Well, where do you see the -4? Inside or outside? And obviously it's outside, and since it's minus, we all know that that means it's going to move down 4. So we got to graph f of x, then we got to graph g of x. So let's graph f of x first. Okay. So we're going to type it in. And I forgot. Half x squared plus 1. So half x squared plus 1. Enter. So obviously it should look like a U because if you ever see the 2, it's a U. So we go to the table. Let's graph enough points so it actually looks like a U. Again, you don't need to graph the decimal ones. So 0, 1, 2, 3, and I don't think 4, 9 is going to fit. So not much is going to fit. So 0, 1, it was 2, 3, and it was -2, +3. And if you try to graph the next point, it was going to be 4, 9, but that's too high up. So I know it's not the most interesting U, but we can just draw that. Don't forget to draw arrows, and don't forget to label it. Its name is f of x. Okay, so now the next one says g of x is just f of x minus 4, and we all just said that makes it move down 4. So take each point and move down 4. 1, 2, 3, 4. So there's the new point. Go down 4. 1, 2, 3, 4. 1, 2, 3, 4. And what do you know? It looks just like the other U, just move down 4. So like I said, most of this is easy. Now you need to write the new equation out for g of x. So here we go. G of x equals, it says just take f of x. So g of x is just f of x minus 4. So why don't we write what f of x is? So think of this as like substitution. Wherever you see an f of x, write half x squared plus 1. And then what's the rest of g of x? It says now minus 4. So now just minus 4. And we just need to combine like terms. So your final answer is g of x equals 1/2 x squared. And then 1 minus 4 is -3. And that's your answer. You came up with the new equation for g of x. Now, how can we prove it's right? Obviously, graph it. And if it looks like the purple g of x graph, you know you came up with the correct equation. So it's not that hard to figure out if you did it right. So that's basically the gist. Now, again, it's easy when we're moving up and down, but when we start moving left and right, that gets a little bit harder on how to write the new equation. So just to give you the heads up for later. Let's see if I can switch the screen. There we go. All right, same kind of question. So here we go. So it says f of x is that, g of x is just f of x, but plus 7. So where do you see the 7? Is it inside or outside the parentheses? It's clearly outside, so that's going to make it move up 7. So we already know it's going to move up 7. So first thing we got to do is we got to make two graphs. Let's graph f of x, and then we'll graph g of x. So 4x squared minus 5. So we'll delete this one. 4x squared. I have terrible memory. I thought it was minus 5. Minus, come on. There we go. Minus 5. Is my pen already starting to die? Nope, not 55. Enter. Okay, go to the table. Control T. Here we go. Okay, so 0, -5, 1, -1. 2, 11 is definitely not going to fit. Let's see what we can get the other way. So like we said again, you're not going to get that many that fit because the thing about quadratics are they go up so fast that there's not many points you can usually graph. Like usually it's 3 to 5 points you can fit. So 0, -5, 1, -1. So here we go. 0, -5. Whoops. So 0, -5, 1, -1, and it was -1, -1. So here we go. Draw arrows, and this one's name is f of x. Don't forget to label it. Okay, what's g of x? Well, g of x is just f of x moved up 7. So again, take each point that we just plotted and add 7. 1, 2, 3, 4, 5, 6, 7. Then go up 7 for that one. And then for the one that's the vertex, go 1, 2, 3, 4, 5, 6, 7. And there's your new graph. And again, how do you know you did it right? Because it should be moved up 7. And that name is g of x. So again, now we need to come up with the equation for that new blue graph. So g of x equals, so what does it say? It says take f of x, you know what, I'll make it in red. Come on. We'll take f of x, and we'll add 7. So let's write f of x, which is 4x squared minus 5. And then what are we going to do to it? We're going to add 7. We're going to add 7 to it. And since it's outside, we're going to put the plus 7 outside. Okay? So g of x equals, it's 4x squared. And now let's combine like terms. Come on. -5 plus 7, and you get +2. So the new equation is, I know I'm getting messy, g of x equals 4x squared plus 2. And how do you know you did it right? Because you would just type it in, and you would see you just made the blue graph. So the basic ones, when you go up and down, is not terrible. Okay, so this part, we're now going to go back to remembering what, the other ways you can move, which are left and right. So you don't even need to come up with the new equation yet. It just says describe the transformation. So where do you see the 4? Is it inside the parentheses or outside? And all of you hopefully just said inside. And remember, plus has 4 letters. So does the word left. So this is going to move left 4. Wow, that was kind of messy. Okay, the next one. That's all you have to do. Just describe the transformation. Left 4. It moved left 4. Okay, where do you see the -5? Inside or outside? It's inside. So again, it's either going left or right. Minus has 5 letters, so does the word right. So this is moving right 5. So if they're asking for the transformation, it's easy. It's just when you have to come up with the new equation, does it get a little bit more difficult. So for 5, again, if you haven't figured this out, I always love to start with the transformation part where it says describe the transformation. So it gives you an idea of where we're going with this question. So where do you see the +3, inside or outside? And hopefully you all said inside, and it's plus. Plus has 4 letters, so does the word left. So left 3. Again, if you want to write a more technical answer, you would write moves left 3 units or shifted left 3 units, but that's perfectly fine to just write left. Okay, it says graph f of x. So this one's going to definitely take a little bit of effort to graph in our calculator. So -2x squared plus x plus 2. Okay, let's see if I can remember that. -2x squared plus, nope, I forgot the squared. Squared plus 2x, was it -2? Plus 2. My memory. And it wasn't even 2x, it was x. Silly Morrow. Okay, we verify that that's actually it. Okie dokie. So enter. Press table, Control T. And again, not many points are going to fit. So let's see what does fit. Actually, in this case, this one fits a little bit better. So -2, -8, -1, -1. Let's start there. So -2, -8, -1, -1. So this one definitely a lot more will fit. 0, 2, 1, 1. Nope, something's wrong. What I have? 0, 2. All right, so I actually just paused the video because I wanted to see what the whole U looks like. And I forgot that this one is going to be a little weird when we graph it because the vertex is not a whole number. So we got to be a little bit careful with how we draw this U. So here we go. So it was at 0, 2, 1, 1. So if you notice, it's not seeming to line up correctly, but that's because it's going to be some decimals. And there is a way to check to see what actually to go up to. And then 2, -4. So you can see how something doesn't look right. That's because it's not, it is balanced, but it's not what we're used to when it's on a, with all whole numbers and integers. So what you can do is to really get a little bit more precise. If you close the table and you press menu, trace, graph trace, let me just show you what you can see. So you can see how like some of these are not crossing at like nice areas, but it will tell you what the maximum is, the vertex. So you see how it's actually at 0.25 and then 2.13. So it's not that pretty. So if you really want to, we just got to take this slow when we graph it. So what it's going to do is, and again, it's kind of hard with this marker, you're just going to dip it slightly above and then just kind of do that. And you're going to draw arrows. So you can see how it's not on an integer where the vertex is. So that's why it was a little bit difficult. So we got to label it f of x. Okay. And now we need to graph the new one. So the new one says move left 3. So let's move this left 3. So again, this is kind of a pain in the butt because they're not the most precise points. So we'll start down here. 1, 2, 3. Okay, then this one, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So again, we're going to try to make almost the, oh goodness, that was not a good start. Silly me. Wow, I'm having so much trouble drawing with this marker. All right, that was pretty bad. Let's try that again. Oh my goodness, come on, marker. Okay, dip it slightly up. And again, just deal with it because my pen is having a lot of trouble. Okay, so it kind of looks like it moved left 3, and the name is g of x. What I care more about is not so much the graph, but how do we come up with this new equation? And that's where it gets a little tough. So, are you guys ready? I'm sure you are. So g of x equals, we got to come up with the new equation. Here we go. So here's the trick. Where do you see the x plus 3? Is it inside or outside? It's inside. So this is why it's different from before. Since the x plus 3 is inside the parentheses, wherever you see an x, you're going to substitute in x plus 3. Okay? So instead of writing negative 2x squared, you're going to write negative 2 parentheses x plus 3. So there's that substituting. And again, my marker is having a lot of trouble with this. So again, instead of x squared, we replace the x with x plus 3. Then the next part says plus x. But like I just said, instead of an x, you're going to substitute in x plus 3. And you didn't really need parentheses there, but I always like to. And then what was the rest of it? Plus 2. So you can see why this is more difficult. You're not just sticking a plus 3 on the outside, like at the end. Since it's inside the parentheses, you got to stick it inside the actual equation. And sometimes the multiple choice leaves the answer like that, but a lot of times it says you have to put your answer in standard form, and that's not standard form. So here's where you guys are going to start groaning, saying, oh my goodness, we have to do this. Hey, let's see if I can get you guys to remember this. What would you do right here? Let me try to remind you. Hey guys, it's so nice, you have to write it twice. Yep, that's right. You got to do box or foil right now. So what I'm going to do is on the side, I'm going to do box and foil for that x plus 3. So this is why it gets difficult, is because you got a lot of work to do now. So we can do box or foil. I'll do foil. So you get x squared, you get 3x, you get 3x again, and you get 9. So if you combine like terms, you just got x squared plus 6x plus 9. So now we got to substitute that in. So here we go. So negative 2, and we just got in the red box that it just became x squared plus 6x plus 9. Okay. Then let's write the rest of it. Plus x plus 3. And again, you can put it in parentheses. You don't have to. And then the plus 2. So now, what should we do? We should probably distribute that negative 2 in. So here we go. I need more space. Negative 2x squared. You get plus 12x plus 18, and we'll still write the plus x plus 3 and that plus 2 at the end. So now you just got a lot of combining like terms. So the negative 2x squared didn't have any friends. 12x plus x is 13x, and 18 plus 2 is 20. And you know you did it right, because if we type this graph in, negative 2x squared plus 13x plus 20, here we go. So, tab, negative 2x squared plus, what was it, 13x plus 20. I was about to say, I'm like, I think something went wrong. Give me a second, guys. Okay, I'm back from my pause, and I'm sure you were all yelling at the TV saying, or the smart board, Mr. Morrow, you distributed a 2 to some of them, not a negative 2. Yep, I made that mistake. Silly me. Or maybe I was just testing you. I know you're all like, no, you're such a liar. Okay, maybe I am. Okay, so guys, we were distributing a negative 2. That's my fault. So that should have been a negative 12. I knew something was wrong with that final equation. So negative 12x That was a negative 18. And again, I know you're like, well, why don't you just edit the video and just fix it? You have no idea how much work it takes to edit these videos. So I'm just going to fix it on the spot. So here we go. It's negative 2x squared. Now, please tell me this is right. Oh my goodness. So negative 12x plus x is negative 11x. And then negative 18 plus 2 is negative 16. Okay, let's see if this one is right. I hope it is. Let me just check my math beforehand. Okay, this should be right now. And should is a keyword. Okay, come on. Let's delete some of this. So it's now negative 11x. Negative, come on, minus 11x. And then what was it, minus 16? Before I type this in. Enter. Oh my goodness, what is going on? Hold on. Okay, I'm back from the pause and I did it again. You guys are going to learn if you ever become a teacher and you try to teach from your house that this is why we should never teach with our kids playing in the room. They're being very good and quiet, but they're distracting me. And of course, I'm being distracted with my math. Oh my goodness, this is why you should never rush your math. It was negative 18 plus 3 plus 2. I totally forgot about the plus 3. You can see that clearly even math teachers, when kids are running around the room, that even they get distracted. So when we do the math again, and this has got to be right this time, you get negative 13. So now let's tweak that one little thing. This is just brutal. I don't think I've ever made this many mistakes in one lesson. Thank goodness. Oh my goodness, was that a disaster. You can see how it moved left 3 finally. So if I'm not proof of you really got to check your math before you do it, I don't know what does. Hopefully there will not be a 3-year-old and a 1-year-old crawling around while you guys are taking the test on this. But there's the answer. Okie dokie, that was brutal. Okay, is this the final question? Please let it be the final question. Okay, here we go. So, just to save time, we're not even going to make the graphs of these. Okay, we're just going to figure out what the transformation is and what the new equation is, because I'm sure we can all graph it on the calculator, and you can see how the equations take a little bit of time. So where do you see the minus 6? Is it inside or outside? Inside. So since it's minus, it's moving right 6. And again, my pen is glitching because what else could go wrong in this lesson? Okay, so we know it's going to move right 6. So where do you see the x minus 6? Is it inside or outside? It's inside. So that means wherever you see an x, you have to substitute in x minus 6. And again, that's very different from earlier in the lesson, because if you notice, these were outside. So it was easy because all you did was stick it outside of the equation. These ones are a little bit harder, and a lot harder actually, because you have to stick it inside as your x. Okay, so we're going to be replacing all those x's with x minus 6's. So g of x equals, oh my goodness, g of x equals x minus 6 squared. So you can see how we replaced that x squared with an x minus 6 squared. Then it was plus 4x. So plus, you know what, I'll make these red so you can see it a little bit better. Plus 4 times x minus 6. And then the rest of it was plus 3. Okay, let me double check I wrote it right before I start doing any math. So it was, instead of x squared, it's x minus 6 squared plus 4 times x minus 6 plus 3. Okay, it is written correctly. Again, it's so nice, you have to write it twice. So we'll do this on the side. How about over here? X minus 6 times x minus 6. Okay, when you do box or foil, and you do all the combinations, oops, you get x squared minus 6x minus 6x plus 36. Okay, so you combine like terms. X squared minus 12x plus 36. So we're going to substitute that in for the first part. So g of x equals, we just got x squared minus 12x plus 36. At the same time, you can distribute that 4 in. So plus 4x minus 24. And then don't forget about that plus 3 at the end. So now all we have to do is combine like terms. And hopefully we do it correctly. So here we go. X squared had no other friends with a square term, so that stays the same. Let's see if I can find all the terms. Negative 12x plus 4x is negative 8x, and that's all for that. And hopefully I'm correct. Negative 8x, and the marker is starting to die. Yay. And then 36 minus 24 is 12. Plus 3 is 15. And that should be the right answer. And if you were to graph this and graph this, you would see that the second graph was right 6 of the previous one. Okay? Now, this last question is an actual regions question. It's not in your packet, but you'll see that this is a multiple choice version of these. And they actually made your lives easier because they didn't even put it in standard form. So it's saying, here's the original graph. What would make the graph move left 3? So remember, if it's moving right or left, it's got to be inside the equation. And if it's left, that means it's going to be a plus 3. So which one has a plus 3 inside the equation? And you can see it's right there. So that was a pretty easy question. Again, this was not one of my best videos, but I hope you learned a lot. And again, I couldn't do it without my fans. So thanks again, guys, for coming to another edition of Morrow Teaches Online. Bye.